max limit. So that's not ideal, but it's okay. We managed to get everything working, and I reckon we'll probably just get started.
Awesome. Okay. Am I working? Cool. So hi everyone, welcome to our WEN specialization evening, brought to you of course by the Part 1 committee with the help of some of our amazing presenters. We hope you're all doing okay during the lockdown and that some of you might have already enjoyed some takeaways last night. So whether you're ready to follow your passion for coding or avoid your least favorite lecture from Part 1, we're hoping that our presenters can share their honest experiences with you about their specialization. So to give you a little idea of how the night's going to run, we're going to go straight into our presenters. It's going to be a bit lengthy, but that's just because it's chock with information. And then we will, if you have any questions, pop them into our chat box, and Zoe's going to pick a few and we'll ask them at the end, just some general ones about all the specs. And then finally, once we've finished all the presentations and a quick Q&A, we're going to open some breakout rooms with all our presenters in them. And if you have any specific questions, you can just pop between the breakout rooms and ask everyone about their spec. So let's get straight into it. We've got the lovely Liz, and she's going to talk about her mechatronics experience.
Hi, I'm Liz. So I'm a bit about me. I'm a Part 2 student studying mechatronics and design conjoint at UOA. So I chose mechatronics because I really wasn't sure of what industry I wanted to work in. And with mechatronics, you can sort of find jobs within electronics, software, civil, and mechanical. Another reason I decided to do mechatronics is because I really enjoyed Engine 131, but I didn't really want to commit to a software job where I'd have to work inside all day. And there's definitely a lot of working hands-on in mechatronics. Another reason that I came is because I initially came to Auckland Uni to study biomedical engineering, but decided I wanted to do mechatronics because I found it was more broad and you can easily get jobs within healthcare anyways. So next, what is mechatronics? Mechatronics is a combo of electrical, mechanical, and software engineering, which focuses on the design, intelligence, control, and programming of smart devices, robots, and intelligent systems. So pretty much it's like a jack of all trades. It's very versatile because you learn a bit of everything. So a bit about the structure of mechatronics at UOA. In Part 2, it's very mechanical focused, with the whole year except for 2 papers done with mechanical. So I'll take you through a bit of the papers to see if it's something that would interest you. So 242 is statics and failure. It's pretty much the statics part of Engine 121 and a combination of ChemMat, which is so pretty much the physics of how things fail. 201 is Introduction to Mechatronics. It's the most mechatronicsy course you'll do within second year, and it's got coding, VEX, robots, and electronics. 235 is Mechanical Design. So design projects, which I'll go on to during my project section. And it's pretty much like NGN 115, where it's mostly project-based, and you get 3 big projects throughout the year and then the final exam. 211 is a follow-on for 111, and that's maths, and the entire course is done with the whole cohort of engineering. 211 is thermofluids. It's a very different course from anything in first year, but it's a lot like chemistry in year 13, but applied quite differently. 222 is dynamics with Hazard, and he teaches the extension pretty much of 121, focusing on kinematics, kinetics, and vibration using MATLAB a lot. 270 is the course that you take without mechanical, and that's software design. It's entirely project-based with no exam and uses C++ for object-oriented programming, and it's super challenging, but also really enjoyable. It's quite like 131. And then 204 is the other whole cohort course where you focus on building professional engineering skills. So into my second year projects. So this project here is VEX robots from the Introduction to Mechatronics course. You pretty much code its journey throughout the course, and the goal is to pick up and deliver the cut. So we'll play the video now. So pretty much your score is based on how well you can get the robot to deliver the cup across the course, keeping in the constraints of the course, which changes each year. So that course is also taught entirely by HASM, and it's about electronics and coding. So the other two big projects in second year is the Woman Design and Build competition, where you build a mechanical automated device to pretty much focus on the delivery of the project brief from the woman competition, which is an actual competition. And you can choose to build that and compete in the woman competition, but unfortunately that was cancelled this year. So that's super hands-on if you're interested in getting some practical experience. And then the second project is also the mechanical one. It's a window washer design project, and that one you pretty much do the design and verification of the transmission mechanisms. So the first project is concept design based, and the window washer is more technical design based. Then in part 3, you really get to explore control systems. This diverges a lot from mechanical engineering, and you do a lot of practical work applying control systems theory into projects. So you learn a lot more about software design, delve deeper into electronics, analog and digital circuit design, and embedded systems. Then finally in part 4, you have the whole year course doing your part 4 project, which is pretty much, you can do any sort of, within mechatronics, you can pretty much focus your project on anything. So I've listed some of also the electives there. You get to choose 3. They're pretty much all tech focused and cover a wide range of fields. So with careers, you can pretty much go into any field. There's such a range of different companies that take you. These are just some of the ones that I know my friends have gone on internships and careers at past at uni. So even if the job description specifies electrical, software, civil, or mechanical, you can still get internships or careers in those fields. There's not really specifically a lot of mechatronics companies in New Zealand, but it's a really expanding field and definitely has lots of development overseas. So what about the culture at UOA? So there's 100 spaces. They're pretty competitive because it's becoming a really popular degree. There's 16 females, which is I think one of the worst ratios in UOA for engineering, but it's pretty fun. It's a typical day for me would be, you normally have 3 lectures in a row where you pretty much move from lecture hall to lecture hall as a mass of people, because for part 2 there's 100 mechatronics and 120 mechanical, so you get to know everyone within your cohort pretty well. So next I'll go into the highlights and the lowlights. So I think the best thing about having a smaller cohort is making new friends. You get to know people a lot closer because you sort of all go through the same projects at the same time, and it's definitely helpful to make new friends so that you can all, it's just good to have someone to check with and do projects with, especially because you can pick for most of the design courses. So I really like mechatronics too because they focus on subjects I enjoy. It's super challenging, and I also joined the student exec mecha this year, which allows me to meet new people and meet industry too. Another highlight was designing the cohort hoodie. So those are my designs at the bottom there. So that was just for the part 2s and the part 4s. I would say the lowlights for mechatronics is like, it's a lot of new content. There's a lot of confusing symbols that are super hard to remember, and they all have different names and different Greek symbols. There's also endless deadlines, which I'm sure you'll find anywhere in engineering. And then probably the hardest part is like when you're sitting in a lecture listening to a derivation and you have no idea what's happening, but it's okay because no one else knows what's happening either. There's also a lot of self-learning involved, especially if the lecturer is a bit lackluster, but I'm sure you'll get that anywhere. And then probably one of the biggest lowlights too is internship hunting can be super stressful, but you just got to know that it's not the end of the world if you don't get an internship for the second year, because they're pretty competitive in mechatronics. So next I'll go on to the top tips for mechatronics. So definitely go to your lectures. They're super helpful, all of them. And then you also want to use your resources. So there's office hours, TAs, and there's a part 2 mechanical and mechatronics assistance centre. Another top tip would be to apply for a variety of internships. Like I said before, you can find internships within anything, even if the job description doesn't specify mechatronics, they will definitely still consider hiring you. And then another good thing is to make friends in your lectures desk tutorials, because you'll see them a lot throughout your degree, and it's super useful to have people to check your answers with, especially in tutorials, because they actually end up accounting for a large percentage of your grade, like the labs. Keep working hard. Mechatronics is a hard specialization, but it'll be worth it in the end. And another top tip that I should really employ myself is to start assignments early. It always seems like a big wave, and then like I'm just stuck like 5 days before with like 0 sleep. So finally, I have some advice for you. If you like design, software, physics, or electrical, and enjoy working hands-on with those 3 main components, then you should definitely take mechatronics. So now I'd like to ask for questions, because since I can't stay to the end for the questioning portion. So if anyone has any questions, feel free to unmute. Cool, so if there's no questions, we'll go.
If you can't unmute.
Oh yeah.
Oh, maybe just if raise your hand. Can you do that? Or yeah, unmute if you can do that as well.
Cool. If there's no questions, we go on to civil and structural with Zoe and Zoe. Oh, someone asked how much electrical is there? So I would say that in 3rd year there's not much electrical in 2nd year, but 3rd year there's definitely a lot more. Electrical is one of my worst subjects probably in 1st year, but I'm sure I'll get through it next year, especially since I like mechatronics so much. So why would I recommend choosing mechatronics over mechanical? For me, I found that most of my friends who did mechanical, it's because they don't like coding. That's sort of the main differential between them. I would prefer mechatronics because you can get mechanical jobs quite easily. But if you really don't like electronics or coding, then I would say choose mechanical. So is Hazem nicer in part 2? No, he's definitely not. He's definitely meaner. We just got this new project and it looks super hard. How many GPA should I get for mechatronics? So that one, this year, I think it's a bit hard to tell because of the grade bump, but I think normally it's like 6.75. This year it was the 2nd highest entry, and I think the lowest that got in was like a 7. So I've heard that it's easy to get a job for something if you do mechanical. Is that true? I don't think it's true. I know a lot of people doing mechatronics that do mechanical or like do project design and get grad roles super easy with it. Yeah, maybe people choose mechanical because it's like you've had more experience in mechanical, but you can definitely find different types of jobs in mechatronics more than mechanical. So what's the difficulty like compared to 1st year? So I think for all the specs, it's a big step up from 1st year to 2nd year, especially because you're getting a lot more specific and deeper into most of the subjects. It's not really baseline learning anymore where you're trying to get everyone up to speed from high school. It definitely goes a lot more in depth. Are there a lot of group projects in mechatronics for 2nd year? So there are for the mechanical design course, but then not really for the mechatronics ones. So only for about 2 of the papers, there's a lot of group projects. Would you still recommend mechatronics if 121 mechanics was not your strong point? Okay, so 121 mechanics was definitely hard for me, and it's still definitely hard for me. You pretty much go in depth in those. But I think if you work hard and you try your best, then it's all good. Okay, I think we'll move on to civil now. Civil and structural with Zoe and Zoe.
Awesome, thank you, Elizabeth. Yeah, so it is myself and Zoe Martin who'll be presenting this one. We've put them in together because we find there is a bit of confusion about what the difference is. The first thing that we're going to talk about is a little bit about us. So I do engineering and a commerce conjoint. So if you do have any questions about conjoints, how it works in 2nd year and onwards, you can ask those questions later as well. My specialization is civil and environmental. It's changed a little bit from when I decided it. So now I think it would be considered as structural specialization, just because I choose the structures electives. And Zoe can introduce herself as well.
Hello, I'm Zoe Martin. I am part 2 I'm currently enrolled in the structures, but I'm considering switching to civil, but all of the papers are in common. So I'll also go over the process of like switching if something goes, you decide that that's something you might want to do. But yeah, part 2's civil is great. So
awesome. So first off, I'm just going to explain the differences between the two, and then Zoe Martin is going to explain a little bit more about the courses and what it's actually like. So civil engineering is all about the creation and improvement of the environments that we live in, and also the way I kind of like to think of it is civil engineering is everything on the ground and below it, and then structural engineering is everything above the ground. So the topics of civil engineering include transport design, so everything to do with roading, hydrology, which is all water, and geotech, which is all about soils and things like that. So I've got a couple pictures just following here, so just giving you a bit of an idea of the different parts of civil. You can see a bit of a transport design there, and also some wastewater treatment coming up next. So it's a super broad subject. You can go into so many different areas and so many different jobs as well. Cool. So now I'll talk a little bit about structural. So it is the design, analysis, construction, and maintenance of structural elements in different sort of buildings and bridges and tunnels and everything like that. So some of the topics include structural design. So that's just buildings pretty much. Materials design as well. So that's thinking about different steels and different materials like wood or concrete. And then seismic design. So that's all about earthquake analysis, which is obviously a huge thing in New Zealand. I've also got a couple of pictures about structural. So yeah, we've got some huge bridge designs. You can be involved in a ton of different, just really huge projects. Like this is one of the longest bridges in the world. Nice big cables on that one. Yeah, but that's just a brief overview. Zoe's going to talk you a little bit through the course structure.
hello. Okay, so I'll go over the specifics of the courses in part 2 and part 3 later. But basically, it used to be a 5-paper course, but then they cut it down to 4 papers and separated civil and structural into 2 specializations. And then my year is the first year they've done that. And I'll go over the specifics of that in a minute. But it's 100 for structural, 180 for civil, and those intakes are based on the job opportunities after university, and they're really good for civil and structural. And there is some flexibility for the intake, but it will be capped at 280. So I'll just go on to the courses now. So these are the part 2 courses, and you get a taste of both structural and civil in the first year. And the structural courses are basically an extension of the statics part of Engine 121, along with the behavior of materials, kind of what you do in Chem Mat, such as failure modes and stress and strain. So that's your timber, your concrete, and your steel. And after these 2 courses, you'll be qualified to sign off on the structural design of a building, even if you continue with civil. So it is a possibility to go into structural if you do civil later on. And then the civil courses, which is your fluid mechanics, transport, and geotech and enviro, are similar kind of to the calculation side of Engine 140, but they cover new concepts. So the fluid mechanics is the behavior of fluids and pipes, reservoirs, pumps, and is quite math focused, but you do quite a few labs in that, which is really fun. And then transport is on surveying and designing highways, and for that you get to go and survey the domain, which is fun. You know, field trips are always good. And then enviro engineering is more information based on like water treatment, pollution, waste management, and it also has a fairly strong chemical side with some lab work for the wastewater treatment. And then geotech is the engineering behavior of soils and rocks. So it's basically what happens underneath the ground when you build something on top of it. And that's quite calculation focused, but you do learn quite a lot about the different soils and rocks, which is really fun. And And now just moving on to the part 3 courses. So it's a continuation of the civil papers in the first year with like a little bit of structural and structural eng 304. And then in Sem 2, you get to pick an elective based on your interests. And in this year, you get to do more design focused papers, because in part 2, it's more like information, just building the foundation, and then you continue on with that in the next years. And then for structural, you've got the geotech in common, so you'll still get to see all your civil mates, but it has definitely more of a structural focus, with courses building with the different materials, and you can continue your civil interests and your elective in semester 2, and the same as civil, you start to do a more design focus. Okay, and then what is it really like? Quite a few misconceptions is that it's an easy course because it doesn't have as high a GPA requirement, but that's mainly because we need lots and lots of civil engineers and structural engineers. So it's not a reflection of whether it's easy or harder. It's just we still have a pretty large course load, but it's manageable as long as you stay on top of all your assignments, and most people manage to have a really good uni life balance. We also have an assistance centre similar to part 1, which is really helpful, benefits of being a large cohort, and it's quite social, especially with the labs, and the Caesar organisation has tons of events for us. Another misconception is that it's just dirt, concrete, wood, and water. It's more about how we design the whole of society, like for the society, infrastructure for society, and just doing it in a way that benefits and helps everyone, which is really nice. Okay, moving on to internships.
Cool. So I'll talk just a little bit about internships in civil and structural. So there are a ton of different opportunities because there are so many jobs out in industry. There are sort of different types of internships you can do as well. So I did one at a structural consultancy, which is more office-based design work, but there's also more construction-based internships as well at places like Downer, which do a lot more sort of roading type things as well, if that's more what you're into and you want to be outside a bit more. But also don't limit yourself to Auckland. There are tons of different opportunities all over New Zealand, and many of them are willing to let you just work there for the 3 months, and they'll like help you figure out where you're going to be living and everything like that. Another avenue to getting internships is through scholarships. So one of the great things about civil and structural is because there are so many huge companies based in New Zealand, they also all offer a ton of scholarships as well. And usually with those scholarships comes the opportunity for summer work or work throughout the year as well, which is pretty cool. There's also summer research scholarships. If you haven't heard about those before, they're basically you're doing research at the university with different PhD students or different lecturers that are conducting research, and you do get paid for that as well. So that's also a great thing to be involved in. We won't take questions right now because we will have the Q&A session at the end, but if there is anything that we don't cover in that Q&A session, you can also email both of us at those email addresses right there. Cool, thank you. And we'll pass on to Hayley, who is presenting about EngSci.
Hi everyone, hopefully you've enjoyed the last couple of presentations. So I will be talking to you about the most mysterious of the specs, if you will, and I'll try and hopefully help you understand what actually is engineering science, because no one knows. So this is the Venn diagram you will get thrown at you if you ask the academics or the lecturers, what is EngSci? So it actually does a pretty good job of explaining it. We've got operations research, data analytics, and computational engineering. So operations research involves a lot of mathematics to optimize processes. Data analytics is sorting through data and moving it into an interpretable form. And computational engineering is just a whole lot of coding. And often what we do is we model physical processes. So that involves using ordinary differential equations, solving it numerically, like your guys' Euler method that you will have done in first year. And then we code that all up in Python and draw some conclusions from it. So the kind of skills involved are your physical sciences, programming, math, and data. So hopefully that explains a little bit more about what EngSci is. And I'm sure some of my personal experiences might help you. So why did I choose EngSci? I love mathematics. I almost did a mathematics degree before I started uni, but then I decided I wanted something applicable. And EngSci is basically that. It's really applied mathematics. I enjoyed 131 coding. Don't let that code scare you. That's from my course this year. There's a really broad scope. So in first sem of second year, you will do a biomechanics course in which you learn about a lot of mechanical concepts, but you apply them to biological and engineered materials. So instead of just looking at flow rate, we're looking at the flow rate of an artery. And then finally, the flexibility. So you just heard Zoe talk about civil. I'm actually taking the geomechanics course because I'm kind of interested in doing geothermal. And you have that flexibility within EngSci to take some electives. So what do we do? Like I sort of talked about before, we've got mechanics of engineered and biological materials, which is just 121, but a little different, I would say, but the same sort of physics involved. Mathematical modeling 2, whole cohort does that. 233 is our coding paper. So we code primarily in Python, which is different from a lot of the other specs. And it is one of the most kind of used and growing languages in industry. So that's really valuable. And EngSci 255, which is solving stock problems and transportation problems. And then we also have 204. 263 is an awesome course. We're doing it at the moment, and you apply everything you learned in first sem and carry out some design projects. And I'll give you an idea of what design looks like in EngSci. And then you get 2 electives. And from these, you're allowed to take anything that relates to science, mathematics, and engineering. So it's really broad. Some people take comp sci if they're interested in coding a lot, software papers. Obviously, I've gone a bit of a different route. I take a mechanical paper and a civil paper, but it's really flexible and it's really up to you. Third year really just follows on a lot of the same things. The one thing I will note is that we take EngSci 314, which is a slightly different mathematics from the rest of the third year courses. And that is a little more statistics heavy because obviously doing all that data analysis, that's a real valuable skill. So a day in the life, lectures with Kevin. He's a bit of a legend in the EngSci department and he's a very good lecturer. Labs in Python and Excel. We do a lot of Python, a lot of Excel, and that's something from my mechanical lab. So it is really quite varied, which I really like. The not so great bits, heaps of coding in Python and Excel. I don't think I realized how much coding is involved, but that is almost basically what a really large part of what we do in EngSci. Our labs are worth a huge part of our grade. So last semester we had 6% coding labs every week, which I won't lie is a bit stressful, but you get really good at coding, I guess. Being split up from your cohort in second semester. So because everyone takes different courses, you don't get to see your friends in all your lectures. So you have to make new friends with the other cohorts, but that's cool too. And you also have to explain what EngSci is to literally everyone all the time, but I love talking about EngSci, so I think that's more of a perk anyway. This is some project work to give you an idea of what our design course is like. So we had to mathematical and computationally, so via a computer, model pressure and copper concentration of an aquifer. So we could recommend how much water they should be taking out. So we had to develop a conceptual model, solve some ODEs in Python, and then forecast what it would look like for the next 30 years. And then we had to present it like you would present to a client if you did this. So it was kind of like we were reporting back to Watercare on how much they should be extracting. And I've got a little clip of our presentation here, plotted here. We've got the bottom line represents an extraction rate of 1 million litres per day, and the top line represents 14 million litres per day. And we've plotted the copper concentrations for each of these. So as you can see in that top region, we have very steep linearly increasing trends, and in the bottom region, we have more gradually linearly increasing trends and even some parabolic decreases. So in order to avoid the impacts of unsafe drinking water and dramatic alterations to the pressure state of the aquifer, our recommendation is that the extraction rate should be reduced to a rate of 8 million litres per day. Sorry, I think we've lost a bit of the video there, but yeah, so you work in a team and it's about also considering stakeholders like iwi and council and locals and all that sort of thing. So it's a really, so we're kind of looking at the technical details and then we have to step back and interpret what does it mean, which is another thing that I think varies from other specs. They'll do those small specific design projects and they are like, whereas ours are kind of really big physical systems and we have to step back and be like, well, what does this actually mean for people? Which I really like about it. So there are so many different career opportunities within InSci because you can change your degree up quite a lot. These are just a few places I know of people interning or working. And I'm interning this summer with PowerCo, and the project I'll be working on is modeling their assets. So the poles that they have for the cables to run the electricity out. They're looking at a renewal of some of their fleet. So it's just about modeling areas where it's going wrong and where it's going right, which is of course very InSci, but I don't think they didn't advertise for InSci or anything. So it's one of those things. I think some other people have said, like mechatronics, you just have to apply and then they'll probably realize that you do have the skills to carry out the job. InSci culture. So we're a pretty small cohort, only like 75 of us. So you really get to know everyone well and you get to know your lecturers well. You get to interact with other cohorts depending on your electives. We're I would say quite an academically driven cohort. So people are pretty motivated and that's really cool because it motivates you, but it can also stress you out a bit. We have an active student club, BISA, and probably the best thing about InSci culture is the InSci and BME trip at the start of the year. Ours was near the mid-sem, so we got to go to Taupo and check out a geothermal plant, and we had some different talks from different industry leaders about their companies and how InSci kind of fits into industry. So yeah, that was awesome social event as well, I will say. So thank you everyone for listening. Let me know if there's any InSci questions at the end or come and chat to me in the breakout rooms. And next we have the lovely Izzy talking to us about biomedical engineering.
All right. Hi, everyone. My name's Izzy. I'm a second year biomedical engineering student and I do a conjoint with commerce as well. So why I chose biomedical engineering. I love learning about the human body and the physiology. So I did consider studying med, but I just didn't really want to get involved with the competitiveness of all that. It's a bit too stressful for me. And I also really like physics and math, so pick the best of both worlds. Also, when I went to the open day, when I was in high school still, they had the needleless injector, which is really helpful for people with diabetes who have to inject themselves a lot throughout the day. It's relatively pain-free and much less gory, I guess, than injecting yourself with a needle. So I thought that was really cool. And actually one of the researchers working on that is one of our lecturers that we had in first semester. So that was pretty cool. So what I didn't realize I got when I chose biomedical engineering was a lot of coding. We share papers with InSci, and as Hayley just mentioned, InSci 233 has a lot of coding that was really quite difficult, but the TAs are always there and the lecturers are really helpful with all that, so that was all good. The content heavy med classes are quite intense and they're huge lecturers, but they're also really helpful with that. Our class is about 30 of us. We're all pictured there in Taupo when we went on our field trip. So it's really good to get to know everyone. It feels more personal. And of course, we get to make friends with the InSci kids too. The cohort also runs barbecues and the field trip to Taupo, of course. So looking ahead at some of the courses that we take, Biomed 221 and 321 are a mix of Chem Mat and Eng 121. So it's looking at statics, at fluids, physics, which we apply to blood flowing through veins and stuff, and also the strength and stress of different materials that you can put in body with implants and stuff. And then we have Biomen's 241 and 341. They're both instrumentation and design papers. So this year in 241, we're designing a colorimeter to measure the color of skin and help identify any problems with blood flow that there might be or any underlying diseases. In part 3, you do a different project. This paper is quite electrical heavy, but again, the lecturers are really helpful and you work in groups so you can all kind of help each other to understand. And also the circuits that you design towards your project. So it's quite cool to see how that all fits in together. NSHA 233 and 331, the lady who described Biomeng last year said it was like 131 on crack, and she was not wrong. It's quite hard coding papers with, as Hayley mentioned, big portions of your grade go toward them. So you just got to make sure you stay on top of that. Because the lectures that we do for that are about the computer systems and the inner workings of computers and the data storage that goes on in them. And then the labs are coding in Python about that. So it's interesting to see the crossover, but also a bit confusing. You also have Colin from MSci 111 as one of your lecturers. So that was pretty cool to see him again. The MedSci and BioSci courses are the Faculty of Medicine and Health Sciences papers. So they're, as I mentioned before, really content heavy, but they've also got heaps of resources available online and they're really helpful. So a normal day for me, I'd have about 3 to 4 lectures. On Fridays, we've only got 1 lab, so that's pretty chill, nice, easy Friday. The lectures are all quite small. As I mentioned before, there's only about 30 of us. So it's a little bit intimidating at the start, but once you get to know all your classmates, they're really friendly and the lecturers are really nice. They're quite interactive and it makes it much easier to focus rather than sitting at the back of the big Fish and Paykel lecture theatres. So on the left, you can see a photo of a model of a fetus that we did for our biosci lab. The TAs are really friendly and eager to help, and you can have up to 3 labs a week I've got this semester, which is really cool to be able to see the practical side of everything that we do. And tutorials are similar to labs in the way that the TAs and the lecturers are always there to help, and they're just usually 1-hour kind of clinics where you work through a set of problems. So next, I've got some examples of some projects that we've done. So on the left is my 241 project at the moment. That's the CAD model of our case for our colorimeter. And then you can see we've got the circuit design down below that we had to do ourselves. And then up the top left is our design for our printed circuit board that we just did over the weekend actually. So we've sent that off and it's going to get made up into a proper circuit board that we can solder all the components together and then actually make our colorimeter, which is pretty cool. In the middle there is 261. That was one of our coding labs on, you might recognize it as MATLAB. And that one there, we were doing the reaction rate of enzymes with different amounts of binding sites in them. So that one was really interesting. And on the right, we've got NSci 233. I'm pretty sure that lab was looking at power stations around the countries and figuring out all the distances between them. So you do cover a lot in what you do. It's quite broad. And next we've got Beyond Uni. So because a lot of it is mathematical modeling and computational techniques, you don't have to go into research like a biomedical science student kid would do. So it's not just about mixing things together in a lab. It's more about modeling, instrumentation, or computers to make happen what you want to happen. This means that you can go pretty much anywhere with your coding skills and data analysis skills. And that leads into lots of research. So there's lots of small businesses that research really interesting things. At an internship talk that I went to a while ago, one of the girls over summer did a internship at a firm that looked at cow sperm. So I thought that was pretty interesting application of everything that we've been learning. And with product development, that's what Fisher and Paykel Healthcare does a lot of. So you might have heard they've been really good with their ventilators to help people's breathing with COVID. So that's quite innovative stuff. And also, as part of our field trip, we talked to a company that measured and then modeled athletes' body stats during training, which allowed them to see if they were recovering from injury correctly by not favoring any side of their body, or just making sure that they were overall healthy and ready to go, competitive ready. And biomedical engineering is not the only way to get into product development or anything in this industry. As you heard before, mechanical, electrical, mechatronics, and software all have similar papers and that develop similar skills. So they're quite easily transferable across to the industry. If you want to be more broad in certain parts around not just doing biological devices, but also if you just like the electricity side of things. Yeah, and so some of the perks of being an Eng-Sci department, because biomedical engineering actually falls under the Eng-Sci department. So you got the small cohorts. Hayley talked a bit about the field trip, so we went on that too. It was really nice to get to know everyone on that trip. And as I said before, the lectures are really small and there's lots of group projects and lab groups. So you get to know your cohort really well. We've got our own building up the hill on Simon Street, the Auckland Bioengineering Institute, where we have a few of our computer labs. And every week that space hosts lectures, so you can get alumni or different people researching in the Auckland area come and talk to you about the research that they're doing, whether it's about medical stuff or having a look at instrumentation as well. BESA also runs lots of social events, which is really good, so keep an eye out for that. And it's really nice. I love being able to learn about something and then going into a lab the next day and being able to see the real life applications in front of you. So yeah, if you've got any questions, come find me in the breakout rooms, and I will pass on to Carissa with electrical engineering.
Awesome, thanks for that, Izzy. Hi everyone. So as you met before, I'm Carissa. I'm a third year student in electrical, and in case you didn't know, it's actually the oldest specialization in UOA. So firstly, a bit about why I'm in electrical engineering in the first place. Growing up, I really love fantasy series. I love reading about magic, like my absolutely favorite book. And for me, electricity is the modern day equivalent of magic. It literally powers everything in our world today. You turn on your switch in your wall, your light magically turns on. The fact that you're on the Zoom call with us and we're not even in within 2 kilometers of each other, that's magic. And I think, yeah, electrical engineering is what enables all of that. So that being said, I wasn't actually always in electrical engineering. For a whole semester, I was actually in ComSys, something I put as my first choice. Like most ComSys students at the time, I put it because I wanted to do a mix of software and hardware, but I discovered that hardware isn't quite the same as physics, and in electrical engineering, you get a lot more deeper into that understanding, and you can still do ComSys electives. I still get my coding fix by picking them as electives, whereas ComSys people can't do electrical electives in third year. Cool. So what is electrical electronic engineering? Pretty obvious, I think. It covers pretty much anything to do with electricity. So that's the generation of electricity in your wind turbines, hydro, the transmission and distribution of it to your houses, and the smaller stuff using the electronics in your laptops and medtech, phones, and so on. Okay, so for you guys, electrical engineering is obviously most like Elect Eng 101. But you also have a bit of 131. The C portion of it is something we use a lot, but we also use MATLAB to model a lot of like our circuit parameters. And there's also quite a bit of math, so MM1. If you guys miss complex numbers and integration, do electrical. The topics include like circuit theory, electronics, hardware, firmware, electromagnetism, which you might remember from higher school. And then as you get into third and fourth year, you do more specialized stuff. So like power systems, radio engineering, and so on. Cool. So what's a typical day for me? Like you, I have lectures to cover a lot of the theory. I'll typically have group meetings. So when we're pretty heavy on like having groups every semester, I've had group assignments or group projects of some sort. And then I'll spend the bulk of my time in labs working on projects. So this might include designing circuits, simulating those circuits, doing PCB layouts. Someone mentioned one before, but that's a PCB. So we like design it, print it, coding the microcontroller that goes in these things, soldering these, testing these in the lab, crying when they don't work. Yeah. So that being said, what sort of projects do you work on in electrical? The first one you do is in second year, it's Electenge 209. I'm not going to talk too much about it because it's exactly the same as the ComSys project. Yeah, so for third year projects, the first one I did this year was a lighting design project. For that one, we had to lay out like the lights in a building. We worked with Legrand for that. And the idea is like it had to meet New Zealand standards for glare. We also had to make it, affordable, and we did some cross pricing and worked out how many solar powers, solar panels would need just to power the whole building's lights. Yeah, I've actually found that project kind of boring, but some people really like the creative aspect of it. And yeah, like it's really relevant project if you're interested in doing building services. The next one is the anti-collision system, and that's actually the picture on the left. That's my favorite project we've done so far. So I don't know if you can see in the picture, there's like a little light in it. It appears as a constant light source, but it's actually what we call a PWM signal. So it's turning on and off at 1000 hertz, 1000 times a second. And the idea of this project is that would be like modeling the headlight, or the brake lights of a car. And through that, the car behind it could receive that signal and find out how fast the car ahead of it was moving, because it's encoded in the length of time in which that light's turned on. So even though it appears constant, yeah, it's actually got some information encoded in that light. So that was pretty cool. And we did an entirely like analog design. We built it and we worked with Hella for that. And finally, the project I'm working on right now is making a flyback converter, which is really relevant if you're interested in doing power electronics. It enables, like how you can use your mains power to charge your phone and without blowing it up. And for that, actually, Fisher & Paykel is sponsoring that project. So one of the cool things about electrical projects is they usually get industry to sponsor or judge the projects, and they often give prizes to the top 3 teams and internships, and you get a pretty good idea of what it might be like to work on a real project with an industry. So there is quite a bit of stuff I don't like about engineering. Honestly, it can be really hard. Someone mentioned this before, but second year is a huge step up from first year. There is also a lot of math, something I didn't know going in. So if you love math, it's great. Debugging as well. If you hate debugging in 131, now you're going to have to debug your hardware as well as the code. And it's like, which one is the thing that's not working? The projects suck up all of your time. I practically live in the engineering building, like in the last 2 weeks of uni. The internships can be a little bit hard to get in second year. I'd probably recommend getting general hours, but by third year, it's a lot easier. You will have William again, and his exams don't get easier. And honestly, there aren't too many females in the field, so we could really do more for you. Okay, what do I love about Triple E? The second year is really similar to ComSys and software. We work with them quite a lot, and you can switch between those 3 specializations within second year quite easily. We also, in case you didn't notice, we're really project driven. We have a lot of projects. I think they're cool, and you get to take them home, which is pretty cool. And you also get to like make your own projects at home. I think with a lot of other specializations, the stuff you learn, it's hard to like apply in your own time. But with electrical, you can easily buy your own breadboards and capacitors or steal them from the Unleashed space and just make cool stuff. It's also a good course if you love the electricity aspect of physics. You get exclusive access to the ECSC labs. So if you can't find somewhere to sit, go up to level 5, use your access card to get in, it's okay. The lecturers are really dedicated, and we're actually really world renowned for wireless power transfer. So your wireless, the wireless chargers that Apple uses and a lot of other phones was actually a technology developed in this department at UOA, which is super cool. We don't have too many exams, usually only 2 or 3 a semester. Our classes are small. We do have a Part 2 assistant center, so there's a lot of support. And there's a lot of fields that you can go to, a lot more than I think people generally think. So what sort of careers do people in electrical do? The 2 main ones are power systems. Again, that's to do with the generation of power, the transmission of it. So you might work for Mercury or Transpower if you're interested in that. And the second main thing that people go into is hardware and electronics. That's something I'm more interested in. So that's like creating the electronics used in your, for example, phones, in med technology. Yeah, there's a lot of applications, appliances. But that being said, a lot of people in electrical also go into firmware software jobs if that's something they feel like they're more interested in, because we do have coding papers. You can go into avionics, so doing the electrical part in aircraft engineering and work for spaceships and stuff. And you can also go into research, consulting, and telecommunication, among other things. Who hires us? Hopefully you recognize at least a few of the companies here. The one on the bottom left, Quantified Photonics, is actually where I interned last summer. They make optical test equipment. So your fiber optic cables, which basically use light to transmit data instead of electricity, they hire electrical engineers. I actually did a software internship, not an electrical one, so proof you can do that even if you're you pick that spec. Yep. Cool. Thanks so much for listening. Yeah, hopefully I'll chat to a few guys later, and I'll pass it on to Chantal to talk about our sister specialization, ComSys.
Thank you, Carissa. Hi, everybody. I'm Chantal. I'm a Part 2 Computer Systems Engineering and conjoint with business. So that's super fun. So I'm going to be telling you a little bit about computer systems engineering. Yep, so what is ComSys? So essentially ComSys is the integration of hardware and software. That's ComSys down to its barest bones. It's literally just both of them kind of like mesh together. So you get to learn a bit of both, which I'll touch on later, but that's a fantastic aspect of ComSys. So it's also the continuation of the digital section of ElectEng 101, which is, I think, is what you guys are doing right now. So it's very much the sort of second half of that. So you'll be learning sort of about the embedded systems, the op amps, all that kind of stuff. That's very ComSys. So also, yeah, so we're looking at the hardware, which are, you look in microcontrollers, registers, filters, sensors. You really learn about the physical components that make up real life systems. So it's like so versatile and great. You get to really go in depth about the more physical, the physical way of how things are made, which I love. But you also get that the
the software side of it. So you learn languages such as C, Java, Python. So it's not just electrical, it's not just software, it's the coming together of them both. So why did I choose CompSys? I chose it because I really enjoyed the electrical and software papers from part 1. So it was kind of the natural progression for me because I just really found them interesting and I really enjoyed them. So continuing on with that, I wanted to learn a mix of hardware and software. So I don't want to say I'm a hands-on person. I'm a very theoretical person, but I really enjoyed the more hands-on side of electrical. So actually getting to design things and getting to make things. But I also really enjoyed the coding, the more, as I said, theoretical side of it. So I was like, CompSys is perfect for that. And I love projects. I love working with people. What's something that's great about ECSE in general is you just get to do like great projects with people, and it's so like team orientated. So you just really get to know people and work together towards a common goal, which is just so fun. And yeah, I want to end up in the tech field, but I didn't want to just limit myself to software or electrical. So I just wanted to do them both. Yeah, so a day in my life. So I go to lectures, I go to office hours. I'd say lectures take up a lot, quite a lot of the day. But one good thing, especially in second year, is your lectures are in the afternoon. So no more 8 a.m.s. They mainly start around 12 and they end around 4-ish roughly. But that's not including the labs, which are the next part of the day in my life. So after I attend my lectures and go to office hours, so talking to my lecturers, I go to the labs up on level 5 and I live there for about 3 hours each day, working on projects, hanging out with friends, doing assignments, using the great simulation tools that you need to complete the projects, which I'll touch on soon. And then after that, I'll go home and I'll work on my assignments and I'll study the fundamentals of computer and electrical engineering. So yeah, that's just studying for the more theoretical papers that aren't project-based. So I'll talk about projects because I'm a part 2. This is the main project I've done, I'm currently doing. It's a smart energy monitor. And essentially what that is, it's an energy monitor to measure and display the amount of energy consumed by a household appliance. So what you do is you sort of you simulate the hardware side of it, which is on the left. That you simulate that using LT-Spice, and then you get to sort of transfer that to your own PCB design, which is on the right. Yes, we got to design all of that, which was so fun. You use a software called Altium, and you just get to sort of, and the lecturers take you through step by step, and they really teach you the fundamentals of how to design PCBs and how to, work on these projects. So that's the main one I've done. It's so fun and really enjoyable. And you get to work in a team of around 4 people, and you get to choose your team. So I'm with my friends, and that's really, really fun. So we all just get to hang out a lot. It is a lot of work though. The project's 209, this is the CompSys 209. That's taking up all of my time at the moment, but it's worth, it's worth it. And aside from the analog side of it, you also get to do your coding. So it'll be embedded software design, and you code in C. That's the main language that we use. And so now I'm going to talk to you about courses. So part 2 and part 3 courses. So in part 2, so your semester 1, you do CompSys 201, which is just an extension of the digital part of 101. But it's more, I'd say, it's kind of the more codey side of it. Yeah, so you get to do a bit of code. Like it's embedded software basically, but you also go more into op amps and logic gates and all that stuff. Elect-Eng 209, that is an extension of the first part of 101, so the circuit theory. So yes, if you didn't enjoy the circuit theory, and that's with William as well, so if you didn't enjoy the circuit theory, it's very circuit heavy. And so yes, that's part 2. Part 3, you can see that CompSys is such like an elective, it's very elective heavy. You can really do whatever you want with your degree. If you want to go more electronic, you can. If you want to go more software, you can design it however you want, which is another reason why I chose CompSys. So do CompSys if you like coding, electronics, hands-on group projects, if you want to diversify your skill set, if you want to work at places such as Data Mars or Rocket Lab, you like designing circuits, you liked 101, you like William and 131. Yeah, so basically all that kind of stuff, I would choose CompSys. So careers and internships, there are so many different options for CompSys. You can go the electrical route or the software route. So your internships will be either like electrical internships or software internships, but you can do both. So you can work at places such as Apple, Rocket Lab, Fisher & Paykel Healthcare, Data Mars, Xero, TradeMe. That's only a few that I found. I know lots of people who have gone to other places. Honestly, you could work wherever. Yeah. So I'm going to do a quick little thing about online learning. So this semester it's been online, and it's good because most of our projects we can use simulation tools such as Altium and LTSpice. So that's great. We use Discord and something called Slack to meet our groups. Online labs are great because again we can use our simulation tools such as like Proteus and stuff. Obviously I miss my friends and it's hard to stay motivated sometimes, but it transfers online really well. So you don't need to worry about if being online would hinder your learning. It's more, it's completely fine. The lecturers have done a fantastic job of moving us over. Yep, that's it. So thank you. If you have any questions, just come to my breakout room after this, but I will now be passing on to Ella, who does ChemMat.
Hi everyone, a bit about myself. I'm obviously doing chemical and materials engineering, and I'm currently doing a conjoint as well with commerce, and I'm a Part 3 student. So if you ask me why I chose ChemMat, it's basically I liked chemistry in high school, and most main thing was I really didn't like coding. So my interest was either civil or ChemMat. But I found that I enjoyed Engine 140 and ChemMat 121, so that led me choose ChemMat. So did it turn out how I expected? Yes and no, so not really is my answer. So ChemMat is basically more of process engineering. So what is exactly ChemMat? So as a ChemMat engineer, you would help design, develop, and operate the processes and equipment that turn your raw materials into valuable products. So you make products from conceptual to production, then eventually getting it to the end user. Also, there is actually a bit of MATLAB in second year and third year. So third year is just in the Insight 311, which is not too bad. But in second year, there's one paper that has MATLAB, which I will explain in my next slide. So what will you do in the next 3 years if you pick ChemMat? So like I mentioned before, it's more of process engineering than materials. So the bits that I highlighted is the materials papers you would take. So I would say there's 70% that you learn for process and 30% you'll learn for materials. So I think so I would say that it's not really a materials degree, it's more a process degree. So in your Part 3, you do have a MATLAB coding, which is in the ChemMat 203. So it's not that bad because there's actually not much MATLAB. So it's not too bad, but there is a bit of MATLAB. So my next slide. So what do I do in ChemMat? So there's lots of labs, lots of group projects, and lastly, you study, of course. With the labs, there's basically 2 labs per paper. So after each lab, we do have to write a lab report. So we do a lot of lab reports and group projects. And a lot of the group projects is just basically writing a lab report as well. So you have opportunities to study a wide range of industry topics, such as how sugar, milk powder, and methanol, etc., is produced. And yeah, for my next slide. So these are a few of my photos that I took and from the lab papers that I did. So that's the one on the top right is a a heat turbine, a heat exchanger. And then a lot of material papers and labs that I did as well. So these are my few projects that I was involved in. So in my part 2, I was doing methanol production, and this year I'm involved with wastewater treatment that I'm doing this semester as well. So those are like the pictures of the designs that we did. So Haley just did like a, yeah. So this is the geothermal power plant that we designed last semester. So we used Excel and a software tool called HYSYS. So we use that to create these as well. Yeah. So a bit about the KIMAT culture. We have a relative small culture, so 60 to 70 students. And I believe we have the highest rate of females in our cohort as well. So we become really close with each other, and especially with our lecturers. So I'm sure that Thomas is taking KIMAT 121. So I had him in part 2 and part 3. So a lot of the KIMAT lecturers you do have throughout the years. So you become really close and they really care about you and your studies as well. So SEMSA is a club that we have in KIMAT. So I'm part of the exec members there as well. So what it is Chemical Materials Engineering Student Association, and we have opportunities to become close with other KIMAT cohorts. I made lots of friends, and you get to know like the other part 2s and part 4s. And we host events such as the industry tour. So last semester we got to go to Tip Top. So we could see how the industry works in real life, and also the KIMAT Mixer pub quiz. And we also have further opportunities with industry mentors and internship events. So these are the few companies that you might work at. So I luckily have an opportunity this semester with Fonterra, but that we do have opportunities like as Fisher and Paykel's. So you're not specified as a KIMAT engineer. So what generalized, you'll be a chemical engineer, materials engineer, a process engineer, operations engineer, and safety engineer. So those are the few titles that graduates have for KIMAT. So thank you all for listening, and I would like to hand it over to Jess, who will talk you for software.
Guys, sorry, definitely wasn't down the other end of the house. So I'm Jess. I'm a part 3 software engineering student, as you can probably tell from the slide. Yeah, I probably should have prepared slightly better how I was going to introduce myself. So when I was choosing what specialization I was going to take, I had 3 top ones in my mind that I was kind of struggling to decide between, and they were software, biomedical, and civil. So you can probably tell from that I have quite a varied interest. I think they're about as different as you can get within engineering specializations. But ultimately, I chose software because it wasn't going to limit me to where I could work. Really, with the way that the world is moving, I could work in just about any field. If you can think of something that doesn't require software, I will be very impressed. Feel free to tell me. And I also love the idea of creating complex solutions, but right in front of you, that have lots of different parts that have to work together. Oh, thank you. So the pros of software is, I think a lot that people think that anyone can learn to code. So why would I bother with software? You don't just learn to code well. You don't just learn to code, you learn to code well. So you do a lot of looking into what makes good software, what can cause issues with software, not just in the short term, but also in the long term, when inevitably other people are going to come in and work on what you've worked on. Software It has so many projects attached to it. I feel like I don't have many exams. Listening to a few of the other people, I totally forgot that other people have exams for like every paper. I feel sorry for you guys. As I said before, it's applicable in so many different fields. So if I decided I wasn't so interested in doing something in, say, accounting software, I could move and do something in healthcare software, or work somewhere like TradeMe, in whatever you want to say TradeMe does. I can't think of the word right now. You're welcome. So some of the cons that I experienced, I felt like the terminology that some of people used in regards to technology, it was quite a bit of a learning curve for me. I came into engineering, I had never coded before until I did 131. And so I felt like everyone knew what all these things they were talking about were, and I was just alone in the room having no clue what was a controller or something along those lines. But I wasn't the only one in the room. You won't be alone with that. And you can find so many great friends, and that you won't be afraid to ask. I think in general with uni, just don't be afraid to ask for help. And if you don't understand something. The gender ratio in software is not great. It's kind of interesting coming off ChemMat to software, which I believe is currently the second lowest percentage of women. But I think coming to engineering, we're probably all a bit used to that. And it's not something that comes up a lot, really. You're still doing the exact same thing as everyone else. You have the same skills, and you're definitely on the same level. Because I hadn't coded before, there were times that I really felt like it was a steep learning curve. And everyone says the jump to second year can be a lot, but there's so much support. We have a Part 2 assistance centre as well, which is really valuable. A lot of our tutors are so awesome. Most of them are just either Part 3 or Part 4 students. And so you really become friends with them, and then you can always just flick them a message if you're trying to work on something and you're not quite understanding why this isn't printing out how you thought it was going to, or something along those lines. So one of my favorite things about software is CISA, which is the best student association, which I'm definitely not biased about. We also have the best pizza. Not sure how well you'll be able to tell on the picture with the big all the people down the bottom, but those are all meter-long pizzas from Presto. I highly recommend, if you haven't tried them, to try Presto. And we also have spent about $10,000 on pizza this year alone. You can also see the wonderful exec from this year. I'm a part of it, and we've planned some really awesome social events, but we also do a lot to connect with industry. We actually currently have some internship roles that are being advertised solely through CISA. So they're not available to anyone outside of the Software Engineering Students Association. And we do all your classic things like CVs, interview workshops, industry nights. And we also have a really cool mentoring program, which is just a great way to connect with people outside of your year. My current mentor is actually working at Microsoft in Canada. So it's really awesome, the kind of people that get involved with that. Oh, the photo seems to have changed color a bit, so you can't read the logo there a bit, but software gives you so many different opportunities for internships, and that's not just in New Zealand. I have lots of friends who are going to Australia for the summer or have been to Australia in the past, people working at Google and Canva and Atlassian, who you may not have heard of because I had not until I did software. But if you've ever used Trello, they're the company behind that. Recruitment was something that I didn't realize was going to start so early. The Australian companies will start recruiting in January, which isn't a massive deal, but basically by the time we've gotten to this point, a lot of companies have finished up their recruiting. But that doesn't mean that you're all out of luck. one of the awesome things about software, which I guess you can also participate in other specializations if you want to get into software development, is Summer of Tech. So Summer of Tech basically collate a bunch of different companies who hire through them. They facilitate lots of events for you to get to know those companies and that process. So some companies you may have heard of who hire through them are TradeMe and Xero, who I'm actually currently interviewing with. So there's some really cool opportunities within software, as well as like some awesome smaller companies that you might not have heard of that have a really cool new vision to get involved with. So some of the courses that we have, these are the compulsory courses for your first 2 years. When you get to 4th year, you've got your Part 4 projects and your Eng courses, and that's about it. So the really important one there, I think, is object-oriented programming, which you've obviously all worked in MATLAB and you've started working in C. Object-oriented programming, we look at using Java, which gives you a whole new tool in a software world where you code up objects, which the way someone explained it to me when I was struggling to get my head around it was, you have a human object and they have lots of attributes to them, like you have a hair color and you have a height, and then you have methods like functions in MATLAB or C, which tell you how the things that you can do with that object, which I think is it's a really cool way to code and opens up so many more doors than just using something like C or MATLAB. There's a couple of really awesome project papers here, Software Engineering Design 1 and 2. Through that, I've done some really awesome projects, which I don't have photos of because you would just be staring at a block of code, which probably isn't all that interesting. But some cool projects that we've done through that, I will talk about in a bit. Databases and software architecture and quality assurance really get you into things like understanding that good code and how you can improve on your code. Next one. Oh, I didn't talk about ComSys. Everyone has to take that who's in ECSE. So some of the electives, honestly, there are a bunch of these that weren't electives when I was taking it. They've done a massive revamp of the ECSE courses recently. I'm very jealous personally of the fact that 282 and 284 are electives now, and 370. So they look at algorithms, which are really useful in helping to optimize the things that you're doing and make them run faster. It's very logic math based, which can be interesting, but is not necessarily quite my thing. You have opportunities to work at like both ends of the spectrum and getting down towards the hardware side, but also being like on the front end. So human computer interaction looks a lot at your user interfaces and how to design those for the user. And operating systems is right down at the base end, where we've literally designed a file system for an operating system like Windows or something along those lines. You also, you also have so many other options for electives. So you can take most comp sci courses. If you want to do more hardware stuff, you can do CompSys and ElectEng courses, and any other course that you think would be relevant to your studies and you want to take. You can talk to NASA, who's the head of the director of software, and there's a good chance that he'll be able to get you into it. So the cool projects that I won't show you because it'll just be a bunch of code. We made a New Zealand trivia game, which actually spoke the questions. It was based on Jeopardy. And so using text-to-speech to read out your text on your screen. Recently, we've created a scheduling algorithm and visualizing that to show how it's processing through the code, which is a really interesting way of visualizing how that process is working, which you do when you're designing, but you don't ever really get to see. At the moment, I'm designing an Android app, which is like a marketplace. I've only just started that project, so there's not too much I can tell you about that, but I am really excited about it. And then, like I mentioned before, designing a file system for an operating system and getting right down to how we actually make our computers run like we know them to. My advice when it comes to choosing your specialization would definitely be to pick what you enjoy. If you're not doing what you enjoy, it's going to be way harder than if you think it might be challenging, but you'll still enjoy it along the way. There are so many resources that are available to you, so make use of them. I really found the Part 2 blogs really helpful. And so make great use of those and don't be afraid to ask questions. If you have connections to people in other parts, ask them a million questions like I did. They won't mind for the most part. So if you do want to chat with me, come on over to my breakout room, or you can reach out to me on social media or email me. You'll be able to find that on the slides in the recording. But yeah, thank you so much. And I'm going to hand over to Felicia now.
Hello, I'm Felicia. I'm in Part 3 Mechanical and I do an arts conjoint. So the faculty website describes mechanical engineering as design, develop, install, operate, and maintain the systems that shape modern society. So that's quite a vague and highty-tighty description, but it's quite broad. So I'll get into that a little bit later. But basically, the first year papers that are most similar are Engine 115, Chemat 121, and Engine 121. And it's basically a few of our papers are basically those on steroids. We build on dynamics, and we even study the dynamics of fluids. And then we combine statics with materials, hence the name mechanics of materials. We share quite a few of our papers with mechatronics. Instead of doing the software and electrical type papers, we mainly do design papers, which are my personal favorite. We do very minimal coding in mechanical engineering. But next I'll kind of talk more about our projects. In Part 2, we've got 3 main group projects. I think Liz talked about the first 2, the Warman design competition where we build a robot, and then the window washer and gantry project, which is kind of the first experience of very technical application of theory, and it's to do with calculating load requirements and selecting components for the window washer. And then in second semester we do the urban transport project, which is in my cohort it was the first time they ran it, but basically you're working in groups of 4 and you design different components of a car. So it was the brakes, steering, the chassis, and the power requirements. And the design projects are part of the manufacturing papers, and you learn the theory for the projects along the way, which is quite obviously very useful. So in Part 3, we use a lot of software to simulate our designs, and then we get to actually make it in real life. So that little box on the first top 2 pictures, we got to CAD up our design and simulate it on CAD. So we were working with mechanisms and trying to get a ball from one side of the box to the other, and we could simulate that on CAD to travel to within exactly 5 seconds. And then we got to print it, 3D print it, and then laser cut it and build it in real life. So that was really cool. And the bracket down there, we drew that up on CAD, and then we got to test it on ANSYS, which is basically where we could look at loads and deflections and the deformation of the part. And then we got to CNC mill it and see it in action at the Newmarket campus, which is that little picture down there. So I went to this event 2 years ago, and I was told, if you like 115 and using CAD, you should do the spec. And so far, we've used CAD in every project in every semester this year, every semester since first year. And an unpopular opinion, but I quite like group projects. And again, we have at least one group project
in every semester. And I wanted to work, help the environment and work in sustainability, which is why I decided to do engineering in the first place. And I like the tangible design aspects of mechanical rather than like civil and environmental engineering. I don't really know what they do, but you know, it's like you get to test out your projects and like actually like, you know, take it home and such. And I thought I could go down the environmental route down the pipeline. And that leads me to my next point. Mechanical engineering is one of the oldest forms of engineering, so it's very integrated in a lot of different fields, even in places you didn't think were applicable. There's a range of different industries and sectors you can work in, from healthcare, transport, automotive, energy, manufacturing. I'm working at Downer this summer, but these are just a few examples of places where you can work as a mechanical engineer. And last slide. So contrary to popular belief, it's a little bit more than just cars and gears in mechanical engineering. Although we do kind of learn about them, it's just basically like the foundations for the projects and such that we work on. Like all the other specializations, it is quite a jump from first year to second year, and then it is another jump to third year. There's only about 15% of girls in mechanical. I've only ever had 2 female lecturers since first year, and one of them actually left. But don't let this stop you. We always want more females in mechanical, and I've actually made it one of my personal goals to befriend all the girls in my classes, which is not too hard because there's only about 20 of us. And in the classes that we don't share with mechatronics, only about 20 people show up. So especially during COVID times, and half of us are girls anyway, so you get close to your cohort. Day to day, most of our time is spent working on assignments and projects rather than like studying for tests and exams. The projects are worth up to 50% of the grade. The projects are worth up to 50% of a grade. So yeah, they're quite hefty. And then one last point about mechanical engineering, we don't get any electives until 4th year, which for me is one less choice to think about. And I think it's great that we get to kind of dabble in a lot of different aspects of mechanical engineering, since it is quite broad. And in part 4, other than in part 4, other than the part 4 project, you only have 2 compulsory papers. So half of them are electives, and you can sort of pick and choose what you want to do. So that's all from me. Thank you for listening. And yeah, we'll get to the next part of this evening.
Okay, so just a little bit of information on if you decide that you want to change your specialization. So it's not the end of the world if you get into a specialization that you chose and you don't like it and you want to switch to another one. It can be done, it's fine. So the first thing that you want to do is you want to, after you've studied at least 1 semester in your part 2 spec, then you go and you contact the engineering student center, which is like on the 1st floor of the engineering building at the end of the semester, and they will be able to advise you on all of the details. But the main thing to note is that the changes are based on your GPA and the spaces available in the specializations. So even if you don't like your specialization, then it's a good idea to keep your GPA up, because that will allow you to like have the most flexibility in which one you could switch to. And you may not be given all of the credit for the previous courses that you've done, and so you might have to like take some courses again over summer school, or maybe double up and have 5 in the semester next year. But it's not the end of the world. You can always do summer school, and it's definitely an option if you want. to switch, and there are the links and an email that you can ask any questions. So yeah.
Perfect. Okay, so I am Julia. I'm the Part 1 rep for WEN, and I just wanted to give a little outro before we head into the Q&A breakout rooms. So first of all, thank you for all the speakers for coming and giving us some of your insight and wisdom, and hopefully for a lot of you that's kind of cleared things up, or at least giving you some info about where to find some resources. So for the Q&A part of the evening, we will have breakout rooms assigned to each different specialization, and we'll have about 20 minutes or so where you can ask anyone or ask people the questions that you have. And also just to recap what Jess was saying, if you're still unsure, there's the Part 2 blogs, which I think a lot of people forget about, and those are really good resources to use to see what people are experiencing day to day. So yeah, thank you all for coming, and you can start going into the breakout rooms, I believe, now. So yeah, so each spec will be assigned to a different breakout room, and then you can just go in between them to ask your questions. So yeah, I think that's all the info, right, Zoe?
Yeah. If you just go on to breakout rooms at the bottom, then you should be able to join anyone that you want to.
Just a quick note. Somebody asked, by when do we have to make our decision? I believe the cutoff dates for choosing your spec is, when, do you guys know when it is? It's like roughly it'll be the end of the semester. I think it's like around December, like big early December. I'm pretty sure you have to put in your choices, and you'll put in your top 5 choices. So yeah. When will we know what specialization we get into? They tell you roughly, oh gosh, it's around like January, I think, something like that. Yeah, and they'll let you know. Yeah, so for example, if you're trying to get into for example, software, which is quite competitive, they'll let you know around like January, and if you don't get in, you'll get your second choice. That's normally how it goes. So don't worry about GPA requirements and all that. It's just something that goes with the job. How do we choose our specialization? I'm sure there'll be a link, I believe, that is emailed to you probably sometime soon, or maybe towards the end of the semester, and you'll be taken to a web page, and you'll just like put in your top five choices, and you submit that. Yeah. Okay. Right, so if there are no more questions, is there no mechatronics? There is not, but I recommend going to Felicia's breakout room. She's the one who did mechanical, because mechanical and mechatronics are, they're related. So I'd go to her breakout room if you have any questions about that. Right, do all the speakers, sorry, but I don't, do you not have the breakout room option? How do we, okay,
who can't get into the breakout room, then just direct message me. I'm Zoe, by the way, and then I can, with the one that you want to be in, and I can put you in there from my screen. So all good.
Okay, I'm gonna head over to all the speakers, which everybody like to head over to their one. I'll just wait sort of for everybody to, yes, I'm going to go to ComSys now. Okay.